Good morning everyone and welcome to our Spring Builders Brunch webinar. For those of you that do not know me, my name is Stephen Kay and I'm a partner at Birketts and I head our Housebuilder Sector Group. This morning I'm pleased to say that we're joined by Ross Barron, who'll be talking to us in a moment about passive fire prevention. To introduce Ross, Ross Barron is a Fire Door Managing Surveyor at the TP Group with a wealth of skills and experience in the passive fire protection industry. As a qualified interior architect and associate member of the Institute of Fire Engineers, Ross is a surveyor with comprehensive technical knowledge of current legislation and regulations. He's got previous experience working for Checkmate Fire Solutions and has many fire qualifications and accreditations, and says he's passionate about delivering the highest standards to clients and customers every time. Ross, over to you. Thank you.
Thank you, Stephen. Good morning, all. Thank you all for taking the time to tune in, and a big thank you to Birketts for making today's talk possible. Fire protection undoubtedly is one of the most talked about topics in construction today. The last number of years have brought a much needed wake-up call in terms of fire safety. The standards of fire safety, of course, are ever changing. However, they're hugely reactive to major fire events. That being said, most fires become disasters due to failures by effective design, incorrectly specified or incorrectly installed products. Did you know these very products, which are designed to keep us safe in our schools, hospitals, and the places in which we live, it's not a legal requirement to have a third-party contractor installing them? It's shocking, really. First and foremost, we're a contractor. Our involvement in a particular project comes following a client which has had a fire risk assessment or survey, which has identified a multitude of issues. We would typically hear the same phrase or comment. Building control signed it off at the time, so it must have been compliant. It must be okay. What if I told you the majority of buildings to which we get involved in have fundamental issues with installation or specification from the build stage, and not down to these products degrading over time? Essentially, it was wrong then and it's wrong now. Today, I'm going to demonstrate to you all failings in relation to passive fire protection that are evident throughout our sites in the UK. I'm going to show you real-world examples which have been taken by my colleagues or I in the past 24 months. This talk will demonstrate the disparity between design and fire. It'll show failings in all aspects of passive fire protection. It shows misconceptions of the British standards, and also will show alarming contradictions between the regulations and manufacturers' guidance. Of course, these issues are leading to non-compliant, newly built and refurbished premises. These failings are putting people's lives at risk, and we felt it was our duty to bring to you our talk today, Passive Fire Protection, Getting It Right from the Build Stage, for any of those taking involvement in fire protection products to give you confidence. So, of course, as Steve has alluded to, my initial involvement is in interior architecture. I'm the Fire Door Manager at TP Group under our company TP Passive Fire Protection Solutions. And I hold a range of competencies across fire doors, fire stopping, and intumescent coatings, as well as being an associate member to the Institute of Fire Engineers. So what I'm going to talk to you today about is 11 key topics. But the one thing I want to draw your first attention to is I appreciate there are many people listening in that have little or no involvement with fire protection to those that would consider themselves experts in the field. So we're going to talk about what is passive fire protection. And then I'm going to move on to the building relations to give context to what we're about to talk about. I'm going to speak about new buildings, refurbishments, and building controls responsibilities. Then I'm going to take the magnifying glass and speak about fire doors, fire stopping, and intumescent coatings, common and real-world examples across these sectors of passive fire. Then going to bring you on to operation and maintenance manuals, typically abbreviated as O&M manuals, and ways that a client can monitor compliance. Then going to close the talk out about speaking about latent defects and, unfortunately, the consequences when things go wrong. So, of course, this is an insight from a contractor, a passive fire protection view, an analysis of the failings, design issues, installation methods and misinterpretations of the building regulations. The building regulations, of course, dictate the requirements around passive fire protection and are aimed at securing the health, safety, welfare and convenience of people using or affected by a building. However, of course, as recent history has shown, fundamental failings throughout the build process has led to destroyed buildings, liability cases, and most worryingly, loss of life. So what is passive fire protection? Passive fire protection is an integral component of structural fire protection and fire safety in a building. It attempts to contain fires and slow the spread. We refer to these in the industry as fire-resistant walls, floors, and doors. These are what we refer to when we say compartment walls. And it must be to a defined and predictable period. I will touch on this a bit later. So there are 5 main types of passive fire protection. The first one and most common one being wall fire barriers, which are designed to uphold fire resistance of a wall equal to or above the wall itself. The second most common type is cavity barriers, typically used within a roof space, which restrict the movement of smoke and flame within such a space. And identical to a wall fire barrier, a floor fire barrier is designed to stop the fire spread by horizontal separation between floors. Fire doors, of course, must act in a very similar manner to that of wall and floor fire barriers. However, they need to allow safe egress. And probably the most least talked about element of passive fire protection is structural fire protection. The very structure of steels designed to uphold the structure of the building. They come in 2 forms, an intumescent coating or a fireboarding system, and it's designed to reduce the structural failure time to a predictable level of performance. And here's just a quick visual example of how all of these 5 elements of passive fire work in tandem to create what we refer to as compartment walls. So of course, the Building Regulations 2010, it applies to new and refurbished premises, and it requires that fire-resisting doors and barriers should demonstrate the appropriate performance. However, born out of this document is the approved documents. They provide guidance on how to meet the building regulations in common building situations. The first most common type with regard to fire safety is a document referred to as Approved Document B. Essentially, it states where the what fire rating the compartments and doors should be in certain building situations. Approved Document E is to the resistance to the passage of sound. So essentially, if you're cutting holes in walls and installing fire barriers and doors, there must be paid attention to the sound resistance between these walls. An approved document M is access to and use of buildings, how able-bodied and unable-bodied people interact with buildings to their convenience. So I want to focus in a little bit on approved document B, being the specific one with regard to fire safety. Part B of the regulations in England covers fire safety matters within and around buildings. The approved documents to Part B are in 2 volumes. The first volume being Relating to Dwellings, Volume 1. It includes individual dwellings and sheltered housing, which each unit is self-contained. Volume 2 essentially covers everything else. It covers all houses of multiple occupation, flats, student accommodation, and healthcare premises as well. But of course, it is assisted by some supplementary guidance, such as HCM 0502, which is specific to healthcare. There are 5 main topics covered under the approved document B, and they go from B1 to B5. B1 essentially is means and warning of escape. B2 being the internal fire spread of the linings of the building. B3 being the internal fire spread of the structure. B4, external fire spread. And finally, B5, access and facilities for the fire and rescue service. Essentially, how the fire brigade gets in and out of the building safely in the event of a fire. So of course, all newly built developments must comply with the building regulations and must receive building control approval. Local authorities are responsible for enforcing building regulation. Approval can come through two means, either a private approved inspector or a local run building service. The role of a building control inspector is to ensure that the technical standards are met, i.e. they can perform a compliance role. It is a misconception that they provide a guarantee of compliance with the building regulations, and the appointment of building control does not remove the obligation of the person carrying out the work to achieve compliance. Well, let's look at some of the facts. There is no requirement to provide an operation and maintenance manual, which contains fundamental information of the documents such as photographs or the data sheets, to building control or the fire service on completion of the project. The inspectors are not responsible for monitoring build quality. And if you think about it, how can building control be responsible for what is an estimated 26 trades involved in the construction of a new home? They can't be competent in all areas. Okay, I'm going to move on a little bit to fire doors and show you some real world examples and common issues. So what is the difference between a standard door and a fire door? Essentially, a fire door is carried out a test within a furnace, typically in a 3 meter by 3 meter wall, with a door installed and then exposed to high temperatures to measure the rate of failure, and thus resulting in the timeline of how long the door should last. Fire and smoke doors, however, must undergo a further test to ensure no cold smoke penetrates around the frame of the door. The typical types of fire rating of doors typically come in FD 30, 60, 90, and 120. However, doors that are accompanied by an S means they will also offer a cold smoke resistance. So there are two categories of testing around fire doors. The first one being primary test evidence. And primary test evidence, in short, essentially means that all of the components of a door, combined with its door, frame, ironmongery, is assembled, tested in a furnace, and it achieves a certain fire rating. And then from the manufacturer, that assembly is replicated direct to the installer for them to fit within the aperture. Secondary test data typically comes following a primary test. It's a global assessment, is written, which can bring together the results of multiple tests and provide a scope based on all of the evidence. Of course, there's so many combinations of different ironmongery and door types and frames, etc. The logic is that if any of these components were tested together or separately, as long as they've been subjected to the same test, effectively, they should work together in tandem in a fire, but it cannot be guaranteed. So we're going to look at 4 different door cores here, and all of these door cores I'm going to add have all been subjected to the same fire door test. They've all been subjected to the test of BS 476, but visually looking from left to right, you can see a tubular particle door. Of course, it seems less robust than that on the far right. I'm going to talk about this in a minute, but these types of doors, tubular particle doors, are readily available in places like Wix and B&Q. And as we move through the graduated density cores and laminated cores, right up to timber perimeter flamed flaxboard cores, are suitable for more high impact and high usage situations. Let me explain that a little bit further. So on the top left, it is an example of a tubular core door. Its ideal application is in a cupboard or duct. And this is very similar to our graduated density cores and our laminated timber cores. The idea behind this is that, as the example on the top left is less robust than the example on the bottom right, is that the doors open and close far less frequently than the example on the bottom right, which is typically recommended in cross corridors, schools, hospitals, and secure dwellings. Manufacturers out there which supply doors, they specify very key guidance on how doors should be stored. Doors should be stored flat on a level and dry surface and kept clear of the floor on at least 3 robust bearers. They should be stacked to avoid double handling, and also they shouldn't be stacked so they're exposed to daylight, causing discoloration. Door sets with projecting sills, such as vision panels, must have spaces between them so they can avoid damage. I suppose, why would all of this criteria be around fire doors? Well, if you take the example on the left-hand side, this was on a new build. BM Trada, on their approved repair techniques guide, have put out a statement. After adjustment, the leaf should not be proud of the door or frame of more than 1 mil on top or 3 millimeters on the bottom. So it should not be proud of that. Now, as we know, timber, when not stored flat and exposed to moisture, it warps. So you cannot guarantee that door will be effective in a fire scenario. So probably the most common issue we find on site. We spoke a bit earlier about fire resistance of doors and what the rating means, accompanied by an S. So this is new flats. It's 2 doors specified as FT30S. However, digging into the British standards, and I've got a document referenced called BS 8214, which is the Timber Fire Door Resistance Assemblies Guide, it specifies that this detail is suitable. However, it's not suitable for smoke control assemblies. And of course, the PU foam must be tested in a linear gap around the door. Here's a typical example of one done correctly. And again, referencing the same standard, showing that the PU foam is being used in the center and it's been capped off either side with a white intumastic. And again, digging through the details, this situation is suitable for a smoke control assembly. A very common issue we find on site as well is threshold gaps. And what I mean by threshold gaps is the gap between the bottom of the door and the floor covering. Manufacturers typically stipulate different varying degrees of millimeters, which they've tested to, be it 6, 8, or 10 millimeters. However, this is only suitable for fire resistant standards. Let me come to this in a moment. So this example on the far right is in an apartment block. The door is specified as being an FT60S door. However, this has been signed off previously and it's come to light there's been extensive issues. On referencing the technical standards, BS 8214, it specifies that the bottom edge gap must be no more than 3 millimeters from the floor. Now, of course, where this is impractical, there are devices out there to counteract this. So you would work in line with the fire resistance standards of 6, 8, or 10 mil in combination with a flexible edge, known as a drop seal, shown in the bottom right-hand corner. These two come in 2 types. You can either get a face fixed on the door, or you can also have a mortise type which sits within the door itself. Okay, we spoke a little bit about fire and smoke doors and fire-only seals. So a fire and smoke door is typically identified by having an intumescent seal with a graphite or sodium silicate interior, and typically it would be a flat entrance door, a stair core, or a doors protecting a means of escape, or also riser doors. Typically, fire-only doors would typically be expected to see on internal flat doors or toilets. And of course, according to the Door and Hardware Federation, historically, a 10 mil strip was considered to be acceptable for an FT30 door, and a 20 mil strip being acceptable for an FT60. Of course, that was wrong then, and it's wrong now. The following guidance really should come from the manufacturer as to what they've tested with their doors, and this should be followed. However, general guidance they have submitted out as what you should commonly expect to see in the bottom right-hand corner. Perimeter gaps, as you can see on the image on the right-hand side, is probably the most common issue we find on sites, especially with new builds right through to maintenance. The perimeter gap around a door should not exceed 4 millimeters, with the optimum being 3. Fire door leaf gaps are most common issue found throughout the site in terms of compliance. And the perimeter gap around the door is paramount. And the reason being is if you draw your memory back to the last image, where it shows the brush making contact with the door leaf. So that brush make is 4 millimeters. If the gap exceeds 4 millimeters around the door is no longer providing a cold smoke resistance. And of course, over several months, doors can drop, meaning this cold smoke seal is ineffective. So some important checks to take away from what we've just been talking about. Ensure that the specifications have been drafted up by competent individuals. Ensure that they're provided with the fire strategy drawings so they know the specific fire rating and smoke resistance of each door. And of course, we see far too many contracts being awarded just on cost. Consider whether your client may want primary or secondary test data. And of course, the works must be carried out by a competent individual with a relevant third-party certified scheme. We've spoken about storage earlier on and how key that is to ensuring the door is effective. And of course, longer-term projects ensure that that doors were installed earlier on rather than several months later have been checked that the gaps are still in line with tolerance when being handed over. And of course, the trades around the fire door creating the walls ensure they are formed suitably so that the door can be installed to a compliant condition. And finally, the handover, also referred to as the O&M manual, ensure that this includes full detailed information of photographic evidence, certificates of conformity, and evidence of the products used to prove that they work in those scenarios. So just in terms of fire stopping, of course, is tested in a very similar manner to that of a fire door. It's tested in a furnace, it's subjected to extreme temperatures. However, the main difference being is that the service is passing through. So look at the example on the top right-hand side. So that white boarding system you can see is typically referred to as a fire bat system. And just some general rules of thumb as we move to fire stopping. Services that are combustible are typically wrapped in a dark grey or black material, and this expands and crushes the pipe when exposed to high heat. Fire stopping typically comes in the form of E&I 30, 60, 90, and 120. So we typically get a specification like EI 30 or I 30. And what these letters represent is insulation followed by the duration in minutes it takes to provide the fire resistance. A huge issue we have seen over the last number of years as a contractor is house builders splitting the fire stopping across multiple trades. So the example on the left-hand side shows a drywall system, which the drywallers actually installed the fire mastic to the head, well, what we perceive to be fire mastic, and has left clear and obvious gaps to the head. So we did speak about white boarding systems, and if it's black, it usually expands and crushes. This is 4 plastic pipes. As heat is exposed to them, they will melt away, which means you'll be left with 4 holes within your wall. And of course, I'm hoping the example on the right doesn't need too much of an explanation. They've went to the trouble of wrapping the pipe, but never put a fire bat system in place, leaving a big gaping void. When you think about it, would you trust a plumber to install an electrical socket? Why is this being done? Polyurethane expanding foam is also a major issue across fire stopping also. It's typically cited as being fire rated. However, these classifications usually are Class O or B1. These classes are reaction to fire, classifications that are concerned with ignitability, surface spread of the flame, and heat release of characteristics of material. Reaction to fire cannot be misinterpreted as being fire resistant, and the ASFP have issued multiple advisory notes on this. Let me put a real world example to you here. And again, going back to if it's white, it typically doesn't expand. If it's black or dark gray, it expands. Look at example on the top left, 2 plastic pipes in a new build development going through a wall. Approved document B, there is a misinterpretation or a consensus that pipes of less than 40 millimeters do not need to be sealed with a closing device. However, this is massively contrary to manufacturer's guidance. Let me throw an example at you to labor my point. If you can imagine yourself in a 20-foot cubed room and you put a pencil hole between the compartments, How long would it take for that room to fill with smoke to such a thickness you cannot see your hands 18 inches in front of your face? If you think many of you are probably in rooms not even 20 foot cubed, and the answer is 3 minutes and 40 seconds. So let me take you on and show you some, just to speak a little bit more about this. On the left hand side is a manufacturing detail showing the fire bat system in combination with the inch mastic or the black material around the pipes. Imagine a scenario where individuals are sleeping next door to a room which is ablaze. These plastic pipes, of course, represent voids far bigger than a pencil hole. Imagine how quickly it would take for that room to fill with smoke. Huge design issues we've come up against in our time. Look at the example on the right, is a pipe penetrating a wall at the same line as a ceiling structure. Now, in order for us to install our bat system shown on the right-hand side, we must achieve an overlap around the surface. This is between 75 to 100 mil. In this case, we simply cannot do it. The example down the bottom shows a huge cluster of pipes which are bunched together with little or no movement. It restricts the installation of the expanding product to seal the void left behind in a fire scenario. Again, we cannot install compliant details by other trades. Of anything today, I want you to take particular note about what I'm going to talk about, because this is relatively new within the industry. It's come into fruition in the last couple of years. Sprinkler pipes are mainly made of CPVC these days. It's far more cost effective than the old metal type. Unfortunately, what's come to light is some PVC pipes deteriorate rapidly when exposed to caulks, cleaners, duct sealants, and unfortunately, fire-stopping products. Where this corrosion occurs, it creates leaks, breaks, and large-scale water damage to schools, flats, and hospitals. It can take months, sometimes even years later. And one such manufacturer, which is operating in the UK currently, is subject of a multitude of lawsuits. The image which has just appeared shows an example of how this was fire stopped up until recently by creating a foil barrier around the actual pipe, keeping it separated from any fire stop materials, not to encourage any corrosion. Some important checks for you from what we've just spoke about. Obviously ensure that these specifications are created by competent individuals. They must have the fire strategy drawings in order to dictate what fire resistance the barriers need to be. Of course, make sure they're specifying suitable and reputable manufacturers that have test data for their products. And of course, the installers themselves or the company must be accredited to install these products. On the trades, they must ensure they eliminate unnecessary variation costs by allowing adequate room to install these fire products. We've just seen an example with the ceiling height, which ensures that the fire barrier cannot be installed with a suitable 100 mil overlap. And of course, any trades such as plumbers, electricians should be making as small of a void in a wall as possible to minimize the amount of material, and of course that is less cost. And fire stop materials in a similar fashion to doors are very temperamental to extreme temperatures. To ensure they must be stored with it above 5 degrees and less than 30. And of course, on handover, this is fundamental with fire stopping. Ensure that all of the information is being collected in the form of an O&M manual with test data showing how the products are used, photographic evidence of the process before, during, and after. It's the only sure way you know it's been done correctly. And as I touched on earlier on, probably one of the least talked about elements of passive fire protection, but probably the most important, is intumescent coatings on structural steel. So intumescent coatings are tested in a furnace in a very similar manner as to fire doors and fire stopping. However, as structural steel, by very nature of what it is, holds a building up under extreme load. So these tests are carried out whilst the steel is under extreme load and exposed to the same high temperatures to measure the rate of failure. The type of fire resistance It typically comes in I, 30, 60, 90, all the way up to 240 minutes. And of course, the I typically stands for integrity. The one major issue with intumescent coatings is that they're hugely temperamental. And intumescent coatings must be applied over structural steel that has been newly primed. The condition and age of the primer is very important, and it must be compatible with the intumescent product selected. Intumescent coatings is hugely temperamental to temperature. It must be within certain temperature range to be applied. It's hugely temperamental to humidity, and it can be affected if the environment's humidity falls outside certain parameters. And the dew point, which causes water droplets to condense, can affect the curing time. There are two main types of intumescent coatings. First one being water-based, and the second one being solvent-based. And the reason for the separation in the two types is water-based is typically far more cost-effective. However, it's suitable only for C1 and C2 type environments, which are more forgiving environments than heated or unheated buildings that are fully encased. C3 to C5 environments are much more harsh environments, such as industrial areas, swimming pools, or any areas of high humidity. So recently, we were involved in a project where we'd tendered for it, won it, and came to site to do a pre-site walk around. The site team had other ideas by installing several services over the intumescent or over the structural steel, meaning we couldn't apply our intumescent coatings around the surfaces, around the steel itself. Now, the major problem with that is if you're not protecting the steel and it's designed to withhold the structure, it could cause a collapse of the building in a fire scenario. So we spoke about water-based and solvent-based. So the example on the top right-hand corner shows where a water-based product was specified in a solvent-based environment. And this is an example of water-based paint being applied in this type of environment, peeling away. And of course, the example on the bottom right being a priming issue, where priming has been removed from the steel. It's either not being correctly applied on the site, or sorry, in the factory, or it's been scrope off on the site when it's been moved into position. So we know steel is obviously hugely temperamental with intumescent coatings. So it is imperative you have a competent individual designed to create softwares like Steel Calc are designed to give correct loadings of how many microns of paint need to be applied in relation to the steel size to give the correct fire rating. The fire strategy drawings are imperative in order to create these Steel Calc estimations as how much steel should be applied. And of course, ensure reputable products are used from manufacturers such as Sherwin-Williams or Nullifier, which have test data to back up their products. Ensure that the installer is suitably trained and competent to apply intumescent coating. Consider the time of year when you're specifying projects like this, and whether it's water-based or solvent-based, based on when the building will be coming out of the ground. Ensure that the program timing, ensure that no services are in the way or restrict the spraying of the paint. And of course, all intumescent paint installers should regularly check temperature, humidity, and dew point as they're going about their day to ensure they're applying the correct amount of paint and within the right conditions. All of this information should be collated in a handover document with DFT measurements and photographs, and also the linked locations of where this intumescent paint is being applied. So of course, there's quite a lot of technical elements across fire doors and fire stoppings. How can a client monitor this? Well, the benefit of this is that Regulation 38, Part B of Schedule 1 imposes a legal requirement for the fire safety operative carrying out the work to provide fire safety information to the responsible person not later than the date of completion of the work or the date of occupation of the building extension, or whichever is earlier. The unfortunate part about this regulation is it does not specify exactly what should be within that document. It doesn't specify whether it should have certs or photographs, etc. But from a contractor's point of view, we would always recommend you have a third-party certificate. We would always remember you have photographic evidence of the works completed with test details to prove installation methods are not ad hoc. And data sheets, of course, for the material used and delivery notes of proof that that is the material that they've used. Of course, mark location drawings are very important to identify where this paint has been applied. And finally, one of the areas which I don't see being challenged, or I suppose included by most contractors, is what we refer to as a residual risk list, which details if the works could not be carried out in a certain area. Throughout my time, there are certain projects where physically it's not possible to install a fire barrier. If it's not possible, it must be made aware to the client so they can use alternative measures such as sprinkler systems or even fire extinguishers in there just to mitigate the risk. And it's not been done through a lot of contractors I've seen. Born out of Regulation 38 are many softwares on the market. These softwares are basically designed to form the basis of a handover. What they essentially do is each operative has a device in their pocket, and as they go about their day, they record the process of what they're doing. So whether that be a fire door, recording the removal of an existing door, all the way through to the process of it being finished. It has real-time recording, so clients can have access to that from their side. It forms the basis for any good handover to provide to the client or main contractor. And it also controls the health and safety and ensures that the risk assessments are signed each morning before they start. And of course, it monitors cost and productivity as well. And here is just an example of two images of how the Boris system looks, software which we use on the client side. So it shows the process, the tiled image of a door being removed, all the way through its process of the fire-rated mastic and the mineral wool, right through to completion, as well as the third-party certificate number on there. And of course, the image on the right shows the location in which this door has been fitted. So we've spoken about essentially latent defects, and it's taken till now to define them. Well, what is a latent defect? It is a defect in a property that is due to a defect in design, materials, workmanship, or supervision of contractors, or site preparation. Works which existed at the time, but it was not apparent on completion of the building works. Some real-world examples for you. In 2018, a BBC Watchdog live investigation found that two large housing contractors had failed to meet the building regulations and found 37% of homes had no fire barriers installed. This project had been signed off and people inhabiting these homes, putting these inhabitants at risk. Ourselves personally, we've carried out a fire protection works on behalf of a large housing construction company which had extensive issues on 8 large multi-story purpose-built flats built in 2012. The insurance firm had refused to insure these buildings, and unless the works were carried out. In the interim, they were forced to have fire marshals on each and every level of these buildings, 24 hours a day at the cost of £50,000 per annum. Of course, we are finding as a contractor since Grenfell that there's a huge influx of buildings which are being found to have extensive latent defects post the build stage. This is costing the contractors and insurance companies tens of millions of pounds. Following Grenfell, a government testing of glass reinforced plastic doors, are typically referred to as GRP flat entrance doors, found 75% of them had failed the test in the furnace from at least one side, and actions had been outlined over the last couple of years across the GRP composite market to raise the standards. Approved Document B has been since redrafted to clarify its language and content in line with the department's guide for approved documents, as well as trying to ensure that the document uses plain English. And the document has been significantly restructured. In 2006, the 2 volumes of ADB were split between dwelling houses and all other buildings, which we spoke about earlier. This split was inconsistent with other approved documents, and they've now basically moved flats back into volume 1. And of course, the most shocking facts of all of these is there were 334 fire-related fatalities in 2017 and 18, of course, which 71 related to the Grenfell Tower. So it's clear, I'm hoping it's clear from what I've spoken about today, that there's still fundamental failings with regard to passive fire protection happening on our new developments. We have to realise we have a responsibility for all those involved within passive fire protection to get it right the first time. We cannot rely solely on building control as a means to ensure the buildings. We spoke earlier about the 26 trades. How can they be competent? I hope you can take some points from today and use them on your next fire-related project. And the aim is to obviously provide safeguarding to the families inhibited living within these homes and flats in the event of a fire. And of course, our little slogan at the moment being fire imposes risks to everyone, and we all have an involvement to make a change. Thank you for your time, and thank you very much for listening to me. I would love the opportunity, if you have any questions, to put my way to assist. Thank you all.
Thank you, Ross. That was really good, really interesting. Quite technical, but quite scary in places. I think some of those photos of gaps in the fire seals, etc., particularly scary. And that stat towards the end about the 75% of doors testing failing is quite unnerving.
Yes,
we've got a few questions in. If I put those to you,
of course.
First is about British standards and whether there are different British standards applying for different types of premises to determine fire structures.
Yeah, so approved document B is basically the foundation of all fire safety. However, as you deviate into buildings like healthcare or purpose-built flats, there are documents out there, Stephen. So you would have, for example, in healthcare, a document called Health Technical Memorandum 0502, or in flats, you would have a purpose-built guides document issued by the government on that. So it's basically a layer on top of approved document B, but that still forms the foundation.
Okay, thank you. Are there fire foams that are tested for use around a door frame for fire and smoke purposes?
Yes, there are. There is a specific product out there called Blue 60, I believe, manufactured by a company called Astroflame, which has been tested for fire and smoke purposes.
The last question I've got at the moment is, how does the installer know how much intumescent paint to apply to achieve certain fire ratings?
Yeah, so I briefly touched on this and on the important checks, but any contractor worth their salt should carry around a DFT checker. And essentially what it is once the paint is cured, is that they can stick it to the steel and it measures how many microns of paint are on there. And of course, from the specification stage, it would detail what the fire rating is. And obviously they would link the amount of microns to that and make sure they're at least above what's specified at that time. Hopefully that makes sense.
Okay, thank you. How can we ensure our operatives are suitably qualified?
Yeah, so there are various training schemes out there. BM Trada, BRE under a LPCB scheme. You are audited regularly twice a year. You obviously have to meet their criteria. If you contact any of those bodies, they'll be able to give you their criteria, to which there's an office side and an on-site side. And once you meet all that, you should be able to achieve your third-party certification. But it's a slow process and it's rigorous.
Okay. Thank you. So I think we will close it there. Thank you, Ross, for the talk. Very interesting.
Problem. Thank you for your time.
Informative. Thank you all for attending, and thanks again, Ross.
Thank you. No, thank you all. Thanks for your time. Much appreciated.